Oh, would you look at the time? It's math time. Oh, hi, didn't see you there. My name's Marissa Manley, and I'll be discussing a very fantastic statistics topic with you, z-scores and normal distribution. So, before even going into test scores, we're going to need a normal distribution. How do you know it's normal? Well, it's got to be symmetrical about the mean, it must have a total area of 0, and the mean must be about the axis of symmetry. Now, for this curve, there are x values all along this distribution curve. A z-score, once equated, tells you how many standard deviations a specific x value is away from the mean. A negative z-score is below, and a positive z-score is above. So, on a normal distribution curve, every x value has a corresponding z-score, every z-score has a corresponding area, and that area equates to a specific percentage of the total area, or probability. Now, while z-scores can be used for many data types, the example I'll be using for this lesson is test scores in a class. So let's just say a stats class takes a test and some values come out of that. So in this list, I have 20 test scores, and what we can do with this data is calculate the mean and standard deviation. So I'm going to go to stats, calc, one variable stats for list 1, where I put the data in. And here we can see our mean and standard deviation. Now, with a given test score or x value, we can calculate the percentile, which would be the z-score. Now, this mean for this data is 81.6, and we have a standard deviation of 9.24. Now, there's this fantastic, beautiful equation that looks a little something like this that we'll be able to use for this situation, free of charge. By subtracting any given x value, or a test score, subtracting it from the mean and dividing it from the standard deviation, we will have the z-score. But wait, that's not all. With this number, we can find and use this beautiful chart to find out the corresponding area, which will give us the position of the x in relation to the data. So with an x, let's just say of 86, which should be somewhere around here, we can use the equation. The z-score will equal 86 minus the mean of 81.6 divided by the standard deviation, which was 9.24. When you plug this into your calculator, you get a quantity of 0.48. This number is your z-score, which is the distance from the mean that your x is. Now, when you take this quantity and go to your chart, in this case it'll be the positive 1 because we have a positive z-score, we're going to find where 0.48 is. Here are your z-scores. 0.4 go across, and we find that our value is 0.6844. This value states that a score of 86 is 68.44%. The percentile, 68.44% greater than all other test scores. Now, the best part about z-scores is that if you're given any 4 of the 5 quantities in the equation, whether that's the area, the z-score, the x, the mean, or the standard deviation, all you have to do is rearrange the formula to solve for the missing variable. For example, if you're given just the area, percentage, the standard deviation, and the x value, and need to find the mean, all you have to do is convert the quantity of the percentage you were given back to a decimal, find its corresponding z-score, and simply plug in the variables you were given, and rearrange it to find the mean, and voila!